Welcome to our first module on the TEM Design Spiral. Engineering is not simply about building products. It is a continuous journey of thinking, engineering, manufacturing, testing, learning, and improving. In this module, we will explore why great products are created through iterative cycles rather than straight-line processes. We will also see how thinking, engineering, and manufacturing work together to create better solutions with less risk and greater value. Let us begin our journey into the TEM Design Spiral.
By the end of this session, you should understand why engineering is an iterative process rather than a straight line. You will learn how engineers identify needs, create concepts, and make design decisions. You will gain an appreciation of engineering as the process of transforming ideas into working systems. And finally, you will understand why manufacturing considerations must be included from the very beginning of product development. These ideas frame the foundation of the TEM Design Spiral.
Every product around us represents years of engineering knowledge and continuous improvement. From washing machines and smartphones to automobiles and industrial robots, each product has evolved through many cycles of design, testing, and learning. Great products are not created in a single attempt. They are refined over time through experience and innovation. This is the fundamental idea behind the TEM Design Spiral. Throughout this course, we will use the automatic washing machine as our common example. A washing machine is an excellent engineering system because it combines mechanical components, electronics, software, sensors, power systems, manufacturing processes, and user needs. By studying one familiar product in depth, we can understand how the TEM methodology applies to real engineering practice. Modern products are rarely developed by a single engineer. Instead, they are created by teams of specialists working together. Mechanical engineers, electronic engineers, software engineers, manufacturing engineers, designers, and quality engineers all contribute to the final product. The TEM Design Spiral provides a common framework that helps these different disciplines work toward a shared goal. Many people imagine engineering as a straight sequence of steps. First we think, then we design, then we manufacture, and finally we deliver the product. In reality, engineering is much more dynamic. Problems discovered during manufacturing may require redesign. Customer feedback may change the original requirements. Learning happens continuously, and successful products evolve through many iterations. The TEM Design Spiral is built on three major activities. Thinking helps us understand what should be built. Engineering determines how the chosen concept should work. Manufacturing focuses on how we will build and deliver the product efficiently. At every stage, we test, learn, and improve. Each cycle creates more knowledge, reduces risk, and produces better solutions. Thinking is the first pillar of the TEM methodology. Engineers must understand needs, explore opportunities, create concepts, evaluate alternatives, and select the best direction. Good thinking prevents us from solving the wrong problem. The quality of everything that follows depends on the quality of our thinking. Engineering transforms ideas into practical solutions. This involves system design, analysis, simulation, optimization, validation, and preparation for production. Engineering answers one important question: how should the chosen concept actually work? Strong engineering reduces uncertainty and increases confidence in the final product. Manufacturing focuses on turning designs into real products. It includes detailed design, process planning, assembly, quality assurance, and efficient delivery. Manufacturing is not something that happens at the end. It must be considered from the beginning if we want products that are economical, reliable, and scalable. Great products stand on three strong pillars: thinking, engineering, and manufacturing. If any one of these pillars is weak, the entire product is at risk. Success comes when all three work together as a unified system. The TEM Design Spiral represents continuous improvement. Every cycle helps us learn something new. Every test provides valuable feedback. And every iteration creates opportunities for better solutions. This is why engineering is not a straight line. It is an upward spiral of learning and innovation. Engineering rarely follows a perfectly straight path. As we build products, we discover new problems, gain new knowledge, and identify better solutions. Each cycle teaches us something valuable and helps reduce risks early. The products we use today have evolved through many generations of improvement. That is why great engineering is a continuous spiral of building, learning, and refining rather than a single linear process. Concurrent engineering means that thinking, engineering, and manufacturing work together from the very beginning. In the traditional sequential approach, one team completes its work and passes it to the next team. Problems are often discovered late when changes are expensive and time-consuming. In concurrent engineering, all three pillars collaborate throughout the journey. This helps reduce cost, reduce risk, shorten development time, and improve product quality. For a washing machine, this means customer needs, engineering design, and manufacturing constraints are considered together from the start. Design for manufacturing means that we design products so they can be manufactured easily, reliably, and cost-effectively. A bad design may have tight corners, too many screws, thin walls, or complex features that are difficult to mold or assemble. A manufacturable design uses simple geometry, uniform wall thickness, proper radii, ribs where needed, and fewer parts. Good design is not only about function. It must also consider how the product will actually be made. Every engineering decision involves trade-offs. If we reduce cost too much, performance or quality may suffer. If we increase performance, the product may become more expensive or less reliable. If we demand very high quality, we may need more time and cost. Good engineering is not about maximizing one corner of the triangle. It is about finding the right balance for the right application. A washing machine can be understood as a system. It has inputs such as electricity, water, detergent, user commands, and dirty clothes. Inside the system, many hidden processes take place: sensing, control, heating, washing, rinsing, spinning, and draining. The outputs include clean clothes, wastewater, heat, noise, vibration, and information. This black box model helps us understand how engineering systems transform inputs into useful outputs. Thinking tools help engineers understand needs, explore ideas, and define the right problem before jumping to solutions. Brainstorming helps generate many possible ideas. Requirements help capture and prioritize customer needs. QFD helps translate customer needs into technical requirements. Concept selection helps evaluate alternatives and choose the best direction. Good thinking leads to the right problem definition, and that leads to the right solution. Engineering tools help us transform ideas into working solutions. CAD allows us to create models and detailed drawings. Simulation helps us predict performance before building. Electronics and software allow us to create intelligent and controlled systems. Testing helps us validate function, performance, and reliability. Great engineering uses the right tools at the right time. Manufacturing tools help us build products efficiently, consistently, and with high quality. Factories provide facilities, infrastructure, and production systems. Robots improve productivity, precision, and repeatability. CNC machines allow high-precision machining. Quality tools ensure inspection, testing, and continuous improvement. Lean methods help eliminate waste and improve flow. Together, these tools help deliver high-quality products at competitive cost. Engineering rarely follows a perfectly straight path. Real-world problems are discovered along the way. Each cycle teaches us something new. We improve the solution step by step, and risks are reduced early and continuously. The evolution from manual machines to semi-automatic, electronic, smart, and AI-enabled products shows this clearly. We build, we learn, we improve, and we build again.
Products fail when one or more foundations are weak. Weak thinking may lead to the wrong problem, unclear needs, poor concepts, or lack of user focus. Weak engineering may create poor design, inadequate analysis, integration issues, or reliability gaps. Weak manufacturing may cause high cost, quality problems, variation, or difficulty in production. A successful product requires strong foundations in thinking, engineering, and manufacturing together. Many engineering failures begin with common mistakes. Poorly defined needs lead to solving the wrong problem. Jumping too quickly to solutions creates rework and wasted effort. Ignoring trade-offs creates problems later. Poor integration causes subsystems to fail when connected together. Ignoring manufacturing leads to high cost and delays. Insufficient testing leads to failures in the field. Good engineering avoids mistakes, and great engineering learns from them. Before we finish this module, take a moment to reflect on your learning. What is one key idea from today that you found most valuable? How will the TEM Design Spiral help you improve your future designs? In a project you are working on, where are the biggest trade-offs? What common mistake will you try to avoid? Reflection helps engineers learn, improve, and grow professionally. Let us summarize the key messages from this module. Engineering is not a straight line. We spiral upward through cycles of thinking, engineering, manufacturing, testing, and learning. Thinking, engineering, and manufacturing must work together as one integrated system. Every cycle makes our solutions better, reduce risk, and create more value. These principles are not limited to large organizations. They are equally important for individual engineers, university projects, startups, and multinational companies. The scale may change, but the way we think and develop products remains the same. Great products stand on strong foundations and on continuous learning. In the next module, we will study identifying needs and understanding customers, because every successful engineering project begins with understanding the people we design for.